Sound is a form of energy which makes us hear many sounds around us in our everyday life as we hear sound of telephone bell, guitar, violin, etc. Sound travels in the form of waves. A wave is a vibratory disturbance in a medium which carries energy from one point to another. Sound waves in water. If we throw a stone in the still surface of the water in a pond, then the expanding circles called ripples formed. As there is no actual movement of water, only the water molecules vibrates up and down about their fixed position. Ripples or water waves on the surface of water is also a kind of the wave motion. When the sound produced by vibrating body comes to us through air, there is no such actual movement of air from the sound producing body to our ears. Only the sound energy travels through the vibrations of air molecules in the form of sound waves. Sound waves in air are longitudinal waves as when the sound wave passes through the air, the particles in the air vibrate back and forth parallel to the direction of sound waves. When a longitudinal wave travels in a medium, then the particles of the medium vibrate back and forth in the same direction in which the wave travels. When the vibrating particles come closer to one another than they normally are, then there is a momentary reduction in the volume and compression is formed. On the other hand, when the vibrating particles move further apart from each other than they normally are, then there is a momentary increase in the volume and refraction is formed. The water waves formed on the surface of water in a pond are called transverse wave. Transverse waves travel horizontally in a medium. The particles of the medium vibrate up and down in the vertical direction. When the vibrating particles move upward above the zero line of disturbance, they form the elevation or hump, which is called crest. And when the vibrating particles move downward below the zero line of disturbance, they form the depression hollow called trough. When a longitudinal wave passes through a medium like air, then some of the particles of the air crowded together and form the compression, whereas the other particles go farther apart from each other and form rarefaction. The minimum distance in which a sound wave repeats itself is called the wavelength. SI unit of the measuring the wavelength is the meter. Amplitude is the maximum displacement of the particles of the medium from their original undisturbed position, and time period is the time required to produce one complete wave is called the time period of the wave. Frequency, the number of complete waves produced in 1 second is called frequency of the wave. SI unit of frequency is hertz, and velocity, the distance traveled by the wave in 1 second. In the transmission of sound through air, there is no actual movement of air from the sound producing body to our ear. This air layers only vibrate back and forth and transfer the sound energy from one layer to the next layer till it reaches to our ear. A sound producing tuning fork vibrates and push away the pith ball. The prongs of the sound producing tuning fork splash water, so they are vibrating. A ringing electric bell is placed inside the airtight glass jar containing air. We can hear the sound of the ringing bell clearly as air is the medium through which sound propagates. Sound cannot be heard directly on the surface of the moon because there is no air on the moon to carry the sound waves. That's why astronauts who land on the moon talk to one another through the wireless setup using the radio waves. The bell jar containing ringing bell is placed over the plate of a vacuum pump. Air is gradually removed from the bell jar by switching on the vacuum pump. As more and more air is removed from the bell jar, sound of the ringing bell becomes fainter and fainter. The persistence of sound in a big hall due to repeated reflections from the wall, ceiling and floor of the hall is called reverberation. If the reverberation is too long, then the sound became blurred, distorted and confusing due to the overlapping of the different sounds. Modern concert halls are designed for the optimum amount of the reverberation. The nature of the material, as the sound travels slowest in the gases, faster in the liquid and fastest in the solids. The speed of sound depends on the temperature. As the temperature rises, the speed of sound increases. Then the speed of sound depends upon the humidity of the air. If the humidity increases, the speed of sound also increases. The repetition of sound caused by the reflection of sound waves is called an echo. When a person shouts in a big empty hall, we hear his original sound. After a little while, we hear the reflected sound of the shout. This reflected sound is an echo. Quality of sound is also known as timbre. The characteristic of musical sounds which enables us to distinguish between the sounds of same pitch and loudness produced by different musical instruments. The quality of the sound depends on the shape of the sound wave. Pitch is that characteristics of sound by which we can distinguish between different sounds of the same loudness. The pitch of some sounds depends on the frequency of the vibration. The pitch of the sound is directly proportional to its frequency. Greater the frequency of the sound, higher will be its pitch. The loudness of the sound depends upon the amplitude of the sound wave. Greater the amplitude of the sound wave, louder the sound will be. The loudness of the sound depends upon the amplitude of vibration of the source producing the sound wave. The loudness of the sound is measured in decibels. A sound has three characteristics: loudness, pitch and quality. The loudness of a sound is the measure of the sound energy reaching the ear per second. Greater the sound energy reaching our ears per second, louder the sound will appear to be. The loudness of the sound depends on the amplitude of the sound wave. If the sound waves have the smaller amplitude, then the sound will be faint. Quality of sound is also known as timbre. The characteristic of musical sounds which enables us to distinguish between the sounds of same pitch and loudness produced by different musical instruments. The quality of the sound depends on the shape of the sound wave. Ultrasound machine used in hospitals. It produces ultrasound scans of the inner organs of the human body such as liver, gallbladder, pancreas, kidney, uterus and heart, etc. The sounds of frequency higher than 20,000 Hz are known as ultrasonic sounds or ultrasound. These are very high frequency sounds. These cannot be heard by the human beings. Dogs can hear the ultrasonic sounds up to the range of 50,000 Hz. Bats can produce ultrasonic sounds having frequency much beyond 20,000 Hz while screaming. They can hear ultrasonic sounds having frequency up to 1,20,000 Hz. Infrasonic sounds have frequency less than 20 Hz. Earthquakes and some other whales, elephant, rhinoceros also produces infrasonic sounds. The vibration in the eardrum causes a small bone hammer to vibrate. From the hammer, the vibrations are passed on to the second bone anvil and finally to the third bone striatum. The vibrating striatum strikes on the membrane of the oval window and passes its vibration to the liquid colchia. Due to this, the liquid present in the colchia begins to vibrate. The vibrating liquid of the colchia set up the electrical impulses in the nerve cells present in it. These electrical impulses are carried by the auditory nerves to the brain. The brain interprets these electrical impulses as a sound and we get the sensation of hearing. The function of the tiny bones, hammer, anvil and striatum in the middle ear is to increase the strength of vibrations coming from the eardrum before passing them on to the inner ear.